Thank you for listening to the short introduction session dealing with IACS type incidents and specifically dealing with business continuity planning and preparedness, BCP, incident response preparedness, IRP, and disaster recovery planning, DRP. Please note that the term IACS, which is the preferred term used by ISA, and the broadly accepted term ICCS mean the same, and both refer to operation technology, OT systems. Furthermore, this introduction session will describe the incident handling process is according to the vulnerability, likelihood, risk VLR triad, and through using the tabletop exercise TTX methodology at the operator and control room level. My name is Daniel Ehrenreich, and I am an expert in the field of industrial control systems and cybersecurity. The goal of this introduction session and the later available complete session is to help your organization to be better prepared to deal with IACS-related cybersecurity incidents. To reach maximum voice quality, this presentation was created with a top quality text-to-voice program. In order to reach the maximum audience worldwide, this introduction session and later will be available in multiple languages. Before we dive deeply into this topic, let's elaborate on why is the handling of IACS, Now let's discuss briefly the BCP and DRP and the IRP-based cyber defense methodologies. Important to mention that all three functions must be conducted by a single team. The Incident Response Preparedness, IRP, is the most important action, as it must be conducted within minutes of the incident in order to prevent risk to lives, minimize damage to the machinery, and contain the situation. When an incident happens, it is very important not to panic and act carefully. The Business Continuity Preparedness, BCP, is a lifetime activity, and the goal is to prepare alternative operations for the organization by using backup data, services available from subcontractors, preparation of alternate control rooms, alternate communications, etc. The Disaster Recovery Planning, DRP, is highly important, and it includes a range of playbooks prepared for fast restoration of the plant operation. It can be achieved through exercises and drills and following strong BCEP processes. Now let's discuss why is the tabletop exercise TTX or TTE process highly important. First of all, it allows the organization to test its preparedness primarily as related to the entire BCP, DREP, and the IRP processes and the capability of the assigned team. It helps to detect weaknesses related to the knowledge and preparedness of the organization, and consequently, it may lead to specific training programs to resolve the detected gaps. There are several types of T2X exercises at the management level, operation room level, and technical level. Here we will train the team working in the operation and control room. It must instantly involve all the IT managers, the CISO, the control process manager, the Physical Perimeter Security Manager, and also the plant management. Finally, we must ask who shall supervise the TTX process. It must involve internal teams who are not participating in the daily activity, as well as external consultants who can help to detect gaps. Now let's discuss briefly the main reasons for a cyber incident, as this task is critical for correctly handling the cyber incident. According to what is seen on the slide, there are three possibilities for an IACS-related event. First, we must consider the possibility of a failure causing disruption of the normal operation. It might be caused by a hardware failure, an operating system failure, an application program malfunction, or the failure of a specific field sensor controlling the process. Another type of operation malfunction can be caused by an incorrect action of an authorized person. It may be similar to an action caused by an adversary, but caused by a mistaken action of an authorized person. The third possibility is a cyber attack, conducted by an internal attacker, penetrated the physical perimeter, or an external attacker who connected via the internet and compromised the security barrier between the OT and the IT zones, or a supply chain-related action such as a malvertised device or software or hostile action by an external person or entity. Now let's discuss some reasons why an IACS-related incident might occur and try to understand why any kind of cyber attack might happen. First, it might happen due to the exploitation of an unsolved vulnerability, such as caused by legacy hardware that could not be protected, legacy software that could not be patched, or caused by weak perimeter security that created the risk. The second possibility might be an incident that is caused by the motivation of an attacker who was forced to take a specific hostile action by receiving a reward promise by a disgruntled employee, or by an employee who was forced to do that through a direct threat. Finally, a cyber incident might be caused by someone who has the knowledge, who is confident that he can be successful, and considers that task as not a complex action. This slide may help you to understand why some people claim different numbers of incidents during past years, ranging from a few tens to hundreds of thousands, that occurred since the Stuxnet event in 2010. Here we are showing four possibilities for incidents. The first option refers to IT-directed attacks, where the impact includes loss of money, loss of privacy, data leakage to attackers, and finally encryption of the database. The majority of these attacks are ransomware and are not related to the OT operation. The second option is an IT-directed attack that has an indirect impact on the OT zone's operation, and it prevents the normal operation of the OT zone. It may cause billing problems, loss of data, and loss of capability to deliver products or services to customers. The third possibility is an IT-directed attack that has a direct impact on the OT zone's operation. It will happen after the segregating appliance between the IT and the OT zones is compromised. Here the impact can be an operation outage, damage to machines, and risk to lives. The fourth possibility is an attack that has a direct impact on the OT zone's operation. It will be an internally generated attack after the attacker penetrates the OT zone. Again, the impact can be an operation outage, damage to machines, and risk to lives. Finally, we refer to the level of impact on the OT zone caused by any of the possible attack paths mentioned earlier. While it sounds strange, there are only three principal possibilities for harming the business operation continuity in the IACS OT zone. An operation outage is the least severe outcome of an incident. It can be short, lasting only a few hours, can be long-lasting several days, and finally can be extended, lasting for several months. Damage to machinery is obviously more severe and may be rated as repairable damage, or bigger damage that requires refurbishing the machinery, or unrepairable damage to machinery. The replacement of a completely damaged machine may last for many months. Finally, we must refer to the risk to lives, and here we may consider harming just a few people or harming a large number of people, and in the worst case, it can be a severe disaster that impacts a very large number of people. Now let's refer to the illustration of the complete IACS OT defense methodology. Here we explain the process while proceeding from the bottom of the slide to the upper part of the slide. In the lower part of the slide, we see the VLR triad, which takes into consideration the vulnerability level contributed by various weaknesses and the likelihood of an incident. The risk level can be calculated according to the extended formula shown on the slide. It deals with the vulnerability, likelihood, impact level, and built-in resiliency created by deployed cyber defense measures in the OT zone. On the right side, we can see the types of impact as explained earlier in this session. The level of risk can be reduced by the RDC factors such as the use of redundant appliances and deploying complex architectures. Utilizing different type of defense appliances is called diversity. Furthermore, IACS operation must be assured through the PPT triad, training of people, deployment of policies, and deployment of secure technologies. Finally, upon reaching the calculated risk level, to assure operation safety, reliability, and availability, the organization must work on the BCP, the IRP, and the DRP activity. Before we discuss the tabletop exercise TOX topic, which in this case is presenting the process conducted for a combined cycle power plant, CCPOP, let's briefly discuss the principles of the CCOPOP operation. On the slide, you can see a principal structure of the CCPP, and it includes the following parts: supply and storage of gas used for the plant operation, gas turbine operation, heat transfer to boiler operation, steam boiler function and operation, steam turbine operation, electric power generator, on-site step-up transformer to high voltage, protected high voltage, HV feeders. These IACS zones are managed from the on-site control room. An important cybersecurity precondition is that the team managing this facility must be familiar with all plant operations and well aware of the safety zones at the facility. Furthermore, the entire plant must have a strong physical security deployment. As explained later, the TTX processes outlined in the upcoming slides are handled by the same team working in the power plant, and as explained later, it must include 5 key members. Now let's briefly discuss the TTX process, which was originally defined for 10 different scenarios that might occur in a CCPP facility. In this short introduction session, we are going to describe just the first scenario out of 10 scenarios in the complete training program. The chart shown on this slide was carefully prepared to deal with a broad range of incidents applicable for CCPP type facilities, but it can be easily modified to deal with other verticals such as water, sewage, oil and gas, chemical plants, refineries, water desalination plants, and more application verticals. Each scenario starts with the detection of an incident. The following explanation will describe the complete TTX process. The handling of the predefined incident must be conducted with specific experts and finally completed with documentation outlining the details and followed with a detailed report to the assigned stakeholders. Now let's discuss who should be invited and active for this TTX, referring to the handling of an incident at the CCPP facility. Upon detection of an incident, the TTX manager will call 2 out of the 5 assigned members and with their experience start handling the incident. The first and most important person is the plant operation manager designated on the slide as M. His role is to deal with the preparedness and manage the incident response. The second person designated on the slide as P is responsible for physical security and safety. That person represents one or two people dealing with the assigned tasks. The next person designated on the slide as C is filling the role of the organization CISO. His role is to ensure compliance with the technical regulatory requirements. The role of the IT expert designated on the slide as I is to support the IACS team with IT-related cybersecurity expertise. Here we may meet 2 to 4 people dealing with all aspects of network connectivity and cybersecurity. The last function, designated on the slide as S, is the on-site IACS cybersecurity experts. His team may include also 2 to 4 people who are capable of dealing with the on-site industrial process and the maintenance of the computerized appliances. Now let's start with handling an incident included in this session as scenario number 1. The incident indicates that the HMI screen is not getting field updates. Now at this stage, we must decide who will be invited to the incident response team according to the presented scenario and the specific incident. The TTX manager will do the selection according to the detected problem. As clearly seen, we have the option to select people from 5 groups of experts. Important to mention that for the simplicity of this exercise, we invite only 2 types of experts to handle that specific incident. We continue with handling an incident included in this session as scenario number 1. The HMI screen is not getting field updates. Here, as seen on the slide, the TTX manager already decided whom to dispatch to help for this specific incident. As outlined on the slide, he selected to call the IT cybersecurity expert marked as I and the IACS cybersecurity experts marked as S. The IT and the IACS experts shall consult each other and decide on specific incident response-related actions related to the specific event and propose specific actions for handling this incident. The first task for the TTX team must be to determine the level of severity related to financial losses, the risk to business continuity, the possibility of significant damage to the plant, safety-related risk related to equipment, and finally the risk to the lives of people. In order not to complicate this exercise, it is recommended to mark each box on the top according to the severity level with letters H for high, M for medium, and L for low. As seen on the slide, the TTAX team already determined the level of severity related to financial losses, the risk to business continuity, the possibility of significant damage to the plant, safety-related risk related to equipment, and finally the risk to the lives of people. After completion of this task, dealing with severity levels for the 5 criteria, the proposed actions shall be filled into the list of actions starting from A to D, as seen on the slide. The TTX team must take into consideration factors that refer to incident response processes that were practiced in the past, and also considerations referring to the recovery of the operational processes. Obviously, if a certain incident risks the lives of people, handling that risk shall be at the top of the priority list. I mean to say that if the lives of people are at risk, we must not worry about cybersecurity risks and not worry about damages to machinery. We continue with handling an incident included in this session scenario marked as number 1. The HMI screen is not getting field update. The TTX manager, the selected team of IT and IACS experts, who decided that there is no immediate risk of severe damage to equipment and no immediate risk to the lives of people. Their decision is to start handling the incident. According to the list shown on the slide, the control room manager decided to activate the secondary HMI available in the control room. In parallel to that, the team started on-site inspections and initiated restarting the HMI. In addition, the IT manager started to inspect all the IACS zone network components such as switches, firewalls, and routers, and see if any cable was disconnected for any reason. This process may take some minutes. If the fault continues and the HMI does not display real data, the control room manager must perform a controlled plant shutdown. We continue with handling an incident included in this session scenario marked as number 1. The HMI screen is not getting field update. We proceed now with a series of proactive steps that will guide us to the correct and most optimal incident response related decision. We start with a question. Did you detect an anomaly in IACS behavior? Here, the obvious answer to this question is yes. The second question is, does it risk the plant's operation safety? For this question, the answer is not sure because we did not detect a severe malfunction. The third question is, does it risk the plant's normal operation? Here, the obvious answer is yes, because our HMI does not show the real picture of the CCPP operation. In such a case, the obvious decision is to dispatch ICS assistance from the IR team. Someone must help the control room manager to make a decision. We continue with handling an incident included in this session as scenario number 1. The HMI screen is not getting field update. After performing a series of actions as outlined in the slide, now we can trace the decisions initiated by the team of experts. Based on the findings, the team can perform an emergency-type immediate shutdown or perform a controlled shutdown of the system. Following the decision to shut down the CCPP, the final step is to perform a complete investigation, detect the actual problem that caused the HMI related problem, conduct a repair, and restore the operation of the power plant. The final step includes creating a detailed summary of the incident, documenting all the steps conducted by the team, and always creating a report to the related stakeholders. After completion of these actions, the organization must perform a post-event analysis and conduct corrective actions to make sure that such an event will not happen again. Now I am going to summarize this introduction session and explain the SRA triad, which is an important and applicable alternative to the CIA triad used for IT systems. According to principles set for operating safety, the machinery must not hurt people even during its malfunction. The machinery must be designed in a way that incorrect actions by people might not cause a safety-related incident. Finally, when any kind of malfunction happens, the IACS operation must go to fail-safe mode. According to principles of operating reliability, the system must operate reliably with minimum malfunctions caused by the quality of products or design-related problems. Furthermore, operation reliability can be achieved by reliable design and deploying redundant architecture. Business operation continuity shall be built into the system design, and it can be achieved through adherence to organization policies, cybersecurity training of operators and engineers, and maintaining redundant architecture supported by on-site available spare parts. Now, after reviewing the most critical topics in this short introduction session, let's summarize the key actions to be taken by industrial and utility operators in order to assure operation safety, reliability, and availability SRA. Adherence to these principles will help you achieve stronger and more effective cybersecurity. The first principle is that cybersecurity cannot be assured without strong and effective physical security. We must always evaluate who may be interested and motivated to access and harm the industrial facility and what kind of manipulation an attacker can do. Finally, we must deploy physical security measures such as security cameras, monitored doors and gates, etc. The second principle is that operation safety cannot be assured without cybersecurity. We must be well aware of who may be interested in causing harm to our organization, how internal, external, and supply chain cybersecurity incidents might take place, And finally, be aware of manipulations that might lead to safety risk. Finally, IACS experts must realize and act according to guidelines, saying that operation safety shall be handled at the highest possible priority. Now let's discuss what is included in the complete training. Training programs and workshops on IACS and OT cybersecurity on the topic are available in the range of 4 hours to 40 hours, conducted online or in person. All training programs are carefully tuned to the participating audience, according to the preferred length of the training program. In the first session, Part 1 of the complete training program, we will cover Principal IACS architecture and industrial applications. Typical components included in IACS are RTU, PLC, IEGRD, IIoT, Safety Instrument System, SIS. Furthermore, we will discuss how to protect computers that are integrated into IACS. Among these are the engineering station, HMI, process controllers, communications, and protocols. We will discuss the role of the Purdue Enterprise Reference Architecture, PERA, typical cyber attacks affecting IACS operations, differences between attack IACS and IT operations. Finally, we'll elaborate on the dependence between operating safety and cybersecurity. Cyber attacks are caused by a variety of attack procedures. Explain the step-by-step process for attacking IACS operations, and more. In the second session, Part 2 of the complete training program, we will cover internal and external attacks on IACS, such as distributed denial of service DDoS, advanced persistent threat APT, man-in-the-middle MITM, zero-day type attacks, and more. Furthermore, we will deal with a detailed explanation of the Lockheed Martin Cyber Kill Chain LMCKC, analyze cyber attacks through the MITRE A2-CK process, and more. In addition, we explain here the methodology for minimizing the vulnerabilities in IACS operations and principles for secured segregation methods between unrelated zones. In this part of the complete training program, we will also refer to IACS maintenance procedures, including secure remote access to the IACS zone. Furthermore, we will explain the encryption of networks and computers, the authentication of people, and the processes for protecting the organization according to the people, procedures, technologies, PPT triad. This process shall defend the IACS against internal and external attacks through the use of regular and next-generation firewalls, demilitarized zone DMZ architecture, data diodes, and other cybersecurity measures. In the third session, Part 3 of the complete training program, we will cover topics related to IACS cyber defense, intrusion detection system, IDS, security, information, event management SIEM, security operations centers, SOC, security orchestration, automation and response, SOAR. We will refer to protecting industrial plants, buildings, data centers, also according to the redundancy, diversity, complexity, RDC triad, according to the confidentiality, integrity, availability, CI triad, and the safety, reliability, availability, SRA triad. Furthermore, we will cover topics related to cybersecurity incidents that occurred since the Stuxnet event in 2010, and talk about cybersecurity challenges. The explanation will include details on business continuity planning, BCP, disaster recovery preparedness, DRP, incident response planning, IRP, talk about best practices for IACS, cyber defense, and more. The tabletop exercise, TTX methodology. At the complete workshop, we'll describe 10 scenarios related to cyber-secured operation of combined cycle power plants, CCPP. We will review of standards, NIST 882 and IEC 27001 2013. Review of specific ICS-oriented standard, ISA IEC 62443. Finally, describe the principles of secure development for application programs created for HMI computers and programmable logic controllers, PLLOCs. Thank you for attending this IACS Cybersecurity Introduction session. I hope that you found it interesting and useful for protecting your organization. I hope to hear from you later related to various types of consulting and workshop possibilities that support your cybersecurity activity. This introduction session was delivered to you by Daniel Ehrenreich, who operates his activity under SCCAG EJUE, Secure Communications and Control Experts, based in Israel. Daniel brings over 33 years of experience with IACS and OT and is an expert on industrial verticals, such as electric power, water, and other systems. Since 2010, Daniel combined his engineering activity with industrial cybersecurity, consulted and delivered workshop sessions in Israel, Australia, Hong Kong, Poland, Singapore, India, Japan, UAE, and more countries. Previously, Daniel held senior positions with leading firms in Israel, such as Tataran, Waterfall Security, Siemens, and Motorola Solutions, dealing with cyber defense for industrial operations. Daniel was selected as the chairperson for the 8th ICS CyberSec International ICS OT conference planned to occur on 29 November 2023 in Israel. Please feel free to contact me via mail or phone, which are displayed on the slide.